today. We've got kind of a bit to go over, so I am going to be tackling a few different things. So to kind of kick things off real quick, the first big thing I want to go over is I kind of messed up on the previous tutorial. We talked about some stuff with the SDL renderer context, and we need to go over some stuff with that. I apologize, I kind of read through this pretty quickly and didn't really go over some stuff with it properly. Sorry, messages are all around and stuff. So I need to go ahead, I apologize for this. I kind of read through the SDL renderer very, very quickly, so I need to readdress some issues with that. And we'll go over that in just a sec. That's pretty quick. The other thing is I wanted to talk a little bit about the singleton structure that the singleton pattern we ended up using for our game, and why I did some of those design decisions with this and what that means for this game and such. So the first things first, I want to address the singleton structures. Then we're going to go over the renderer, and then we're going to go through and start today's portion, which is getting our game states and stuff managed. So first things first for the singleton structure. The reason for the singleton structure, so first off, singleton structure is generally not very favored. It generally can be done in different ways that sometimes improve it, generally improve it and make it better. I chose this because of a few specific things. It was, first off, it's a much easier structure for us to deal with in this case. We don't have to worry about passing. We could use dependency injection, where we basically create our application state, and every substate and such, we put it into there and we then call it from there. But that requires going through and adding it in each time, and I just didn't want to really deal with that. It's really just kind of a lazy design choice there. Generally, though, that's how that would be done. The big downside to this is that if you split your code up, right now we have all of our code in one single project here, but if you were to split that up, it would actually make it tough to kind of pass around, due to the fact that each of the modules would have its own instance of this whole thing, just because of the design. And you know, I kind of went with this because we're only going to be doing a simple project in this case. It's a very, very simple game. There's not a whole lot to it. So the singleton structure, yes, probably not the best thing to use, but for our project it works. It keeps our code kind of simpler. And it's a design pattern I think that's important to know, and to at least know about, but it definitely is not the best to use here. I'm using it mainly because that's a little bit of an easier one to go through and do real quick. We don't have to worry about a lot of extra stuff, and it's all set to go. So that's kind of my reasoning on the singleton pattern. I know some people might disagree with that or might not think it's best. However, sorry, I'm getting all sorts of notifications here. I'm going to go ahead and exit out of that. Hopefully that'll kind of stop those. And then I am going to go offline here, which I should have done. Yes, okay. So there's all of that. Sorry about that. My Steam is getting all sorts of notifications, which is kind of distracting. So yeah, singleton pattern, maybe not the best choice here, but it'll work. It's a good pattern. It's a good thing to know about as many design patterns as you can generally, and this is a pretty simple, straightforward one. Plus, it keeps our main method pretty short, and it's a pretty simple way to go through and manage our application state. So that's the first thing. The second thing is the renderer. And I apologize for this. I went through and I read this pretty quickly. I didn't really study on it properly. I was trying to make sure I was using a newest version of SDL, and I just kind of rushed through and didn't really pay attention to what this actually is for and how it works. So the SDL renderer is actually not what we want to use for the OpenGL context. The reason for this is that the SDL renderer is meant to render things from within SDL. It's not meant to be a general renderer like I thought it was. This means it could actually render things using like DirectX, for example, in theory, on Windows if that's more efficient. So we actually don't want to use this. There's not a whole lot that changes. The big thing that we're going to want to do, let me go ahead and get this real quick. So SDL create text. Let me find this one for you guys. SDL, GL, context. There we are. So this is actually what we want to end up using, is the SDL2 create context. Now this is very specific. So the renderer is meant to render things like, there's a built-in render this image method that's generally used in tutorials and stuff. That's not what we want. That will render images and things, but we actually want to render our OpenGL stuff, our 3D stuff. And this is what's actually going to let us do this. Remember how I said that we have our window, and then we have our OpenGL context within the window that renders to that we render everything to, that then displays it in the window. This is actually what creates that. And so it's pretty straightforward to use. You've got your quick little example here. So really there's not a whole lot that has to change. I'm going to change some minor things just to clean it up, and then we're going to change what it actually does. So the first things first, we have our renderer here. We're going to change this from render exception to context exception, and actually we'll do GL context exception, just because that's going to make things a little cleaner. And then we're actually going to need to change this to SDL GL context. I believe that's it, right? Right here, SDL GL context, like that. And you'll notice that I didn't actually add the star to indicate it's a pointer. That's because this is actually already set up as a pointer. It's actually set up as like an object, so it's this is actually what it is defined as. So that's why we don't need to add in a second pointer to it. We could, but that's kind of silly at that point. So that's the first thing, is we have this SDL renderer that we're going to have. And this is now going to be SDL GL context. So there's all of that. Now we need to come over here to our window. We need to change that to that, and the same thing there. We need to change this to SDL GL create context. And we're just actually going to pass in the window here, and that's it. And in this case, we need to change that to be a GL exception. And in that case, we'll get our error, and that'll be all good to go. Now, we've gone ahead and done that. However, you remember up here we had these renderer flags, and one of the flags here was present vsync. We still need the vertical sync to be set up. That's so that if your monitor is rendering at 60 frames per second, it synchronizes and does 60 frames per second. On a VR headset, like what we're going to be using later, that's going to change to 90, and we don't want to have that be hard-coded, so we actually need to go through and set this up. And the way that we do that is, if we come over here, we have this method right here. And again, both of these will be in the links below on the YouTube video, and if you want them directly in the chat, you can get them, otherwise you can just Google them. The method we want here is the SDLGL set swap interval. And you can read right here, 0 will go ahead and immediately update everything. It'll automatically go through and render everything, it'll push it, and this can be bad because it can introduce tearing, as discussed before, among other things. So that's not actually what we want. We want 1, which updates, 1 for updates synchronized with the vertical retrace, aka the vertical sync. So we're actually going to use this method, and we need to do that after this right here. And so what we're going to do is we're going to do if SDL swap interval to 1 is greater than, or is less than 0, then we want to also throw an error. And the errors in this case are going to actually be a little bit different handled now. We don't want to give a specific line number, and we also want to update this exception. So we're going to come over here, we're going to just update that real quick, and we're just going to change that to say in window.c++, and we're going to then change this GL context error. And then that will go ahead and do that. In this case, we're going to say error. Actually, that should actually still work. I think it'll still get us an error. Okay. And in this case, we want to say SDL vsync not supported. And I believe that should be the only error we can get, correct? 0 on success, or -1 if the return interval is not supported, and CSDL. Okay, so we can actually use that still. Cool. And so that will go ahead and that will set up vertical sync properly now for this context. And again, I apologize for that. I rushed through. I should have studied that a little bit more rather than just rushing into it. I've been spending a lot of time making sure I understand this now and can describe it a little bit better. So there's all of that. We have our basic vertical sync set up. And so if we go ahead and we can run this now, we will be able to see that this is going to change things just a little bit now, but not a whole lot. We have our window, it's all set to go, no errors of any kind, so we're all set to go. Okay, so now that we have that, we want to go through and do a few more things. The first thing that we're going to want to do is now we're going to want to set up the rendering of everything. So right now, our application is set up so that all it does is check for the key states and that's it. We now want to get it to render everything, and we just want to kind of render a blank screen. Right now our window is doing nothing, so we're going to go through and we're going to fix that. We're actually going to tell the window to push all the rendering stuff at the very end. So we're actually going to need a update method in here. And what all this update method is going to do is it's just going to present everything within our OpenGL stuff to the window. And this is all pretty straightforward. It's nothing too crazy. And it's just going to be SDL2 present. Oh, I gotta find that again. I can never remember that command, man. Swap something. Is that it? No, that is not it. Sorry guys, I am completely forgetting this command right now. Let's see. There it is. SDLGL swap window. So this is going back to our SDLGL create context, which if I bring that up here, we have this swap windows right there. And that is what actually goes through and presents everything to the window and says, hey, go ahead and draw me. The other thing we're going to need as well, and I forgot this last time for the render, we won't forget it this time, is the delete context. So let's go ahead and we'll add that in now. The delete context needs to be called when we are destroying our window. We do SDLGL this, SDLGL context, whoops. And that will go ahead and destroy that. So now we're going to need this, which is how we render everything, and we give it the window argument from before. And that's basically going to go through and render the window each time. So now we need to come over to our application here, and at the end of all of our polling and such, we need to then render our window. And we should probably call this something a little bit more, well, that's actually okay. So that'll go ahead and that'll update our window, which if we go ahead and call this, it's just going to present us with a black screen because right now it's just being cleared to the default color. What we can do to check this out, you can see that's what they're doing here, is we can take this, copy that into there. We need to also not forget to include our include GL/GL. And the big thing with this is it also requires, I believe, windows.h. In that order, yeah, there we go. So this glgl.h is dependent on the windows.h header right here. And so that needs to be included before. So now you can see this is actually clearing the color. So this is our first little tiny bit of OpenGL. And I'm going to explain this real quick. The first command here is GL clear color. What this does is this goes through and tells OpenGL this is what we want the clear color when there's nothing being rendered to show. And so you actually don't generally want this on your main loop. You actually really want to put that up here with all of our application initialization. This is actually going to be whenever we initialize. Well, I'm going to keep it here for now. Basically, you'll see this in a little bit. When we get to our game state handling, our game state has an initialization state, an update state where it's running, and then a destroy state. This clear color will generally go into the initialization state because really you only need to call it once. You don't need to call it every single time through your loop because you're just telling OpenGL what color to use when clearing the screen. So in this case, we're going to set it to red so we can actually see it. Now this command right here, the GL clear with the GL color buffer bit, this is actually an important command. What this does is this actually goes through and clears whatever you tell it to clear. Generally the two that you're going to use is the color buffer bit as well as the depth buffer bit. And basically, and we'll go into this more next weekend when we start going over OpenGL in more depth, but the color buffer bit basically clears all the color information related to the screen currently, and then the buffer bit, depth buffer bit, actually clears all of our depth information. We actually have to store that for certain reasons, which I'm not going to dive into in this video. That's going to be saved for next weekend, and we actually don't really need that right now, so I'm going to get rid of that. Really all we need is this color buffer bit. If we go ahead and we start rendering this, you will see that the window will now change to a red color. And we can of course expand this, we can shrink it, and you'll notice now that before when we did our scaling of our window, it didn't update. But now once we've scaled it and we release the mouse, it actually adjusts the rendering to fit our screen size. So that is the basics for rendering for right now. Now the big thing we have to do, so this is our first part of this, is getting just a basic window where we can render super simple OpenGL2. The next step of this now is to start doing our game state management. Now this is actually going to take a very similar approach to last year's, except we're actually going to do some additional stuff in order to better suit it for frame independent design. And the reason for this is last year, if you'll remember, we actually had some points where the games might run faster or slower depending on what kind of computer you were running everything on. And this year we really want to make sure that this runs the same across each game. So what we are going to do is we're first going to create, and this isn't going to I had a question on IRC. So, okay. Let's continue on from here. Oh, and let me go ahead and actually change this. I just realized we still are titled this episode 2. I'm going to change this to episode 3. To game states. So there's that. And why is it putting our language at other? This should be in English. So there's that. Hopefully that'll make sense. Why is that defaulting to other? Weird. Okay, so anyways, continuing on. So we have all of this set up for the time being with just a basic rendering. So now we need to go through, we need to actually create our game states. So we're going to go to there, add, and actually, let's go ahead and we'll be fancy with all of this. Let's go ahead and we will, I wonder if this will work okay. You know, don't really feel like dealing with that. So we're going to go ahead and we're going to keep doing this the way I've been doing it, because I kind of prefer that. But you can use the class creator there. That's not a bad way to do it. I just prefer to kind of go through it this way right now. So in this case, what we're going to call this is we're going to call this our game state header file. We've got this over here. We're going to move it over to the right side with all our other headers. And basically what this is going to do is this is going to be very similar to our window class, except it's going to have a few specific different things. So we're going to go ahead and we're going to name this game state. And we're going to have some public stuff. We're also going to have some private stuff. Now, in this case, the game state is really not going to be talking at all to the windows. We don't need to pass that in. And our application state is already easily accessible. So for the base game state, we don't actually need to pass anything in. We're going to be able to just create it and go with it. However, and this is very important, we're not going to actually ever be able to create an instance of this class. The reason being is that this class is actually going to be an interface to which we extend. Sorry, I'm typing something on here. So basically what this interface is going to be used for is this is actually going to be used for our basic state management. We really should never actually create a default state like this, so there's going to be a lot of virtual methods in it, and these virtual methods are going to be designed for us to override in the subclasses. This is very similar to what we did last year. There's not a whole lot of differences in everything. And so, for the most part, it'll be pretty straightforward. So we have our virtual method, bool init, which is our initialization method. We have our virtual bool update, virtual bool destroy, and these are basically just going to be set up like so. There isn't a whole lot to these. They're just very, very simple classes that really don't do anything. And what this is going to end up being used for is we will then be able to take these states, extend them into custom classes, and these custom classes are then going to be used for managing our game. So what we actually need is we need to come over here to our application. We need to include in that game state header file. We're going to include game state.h. And we are going to have a pointer to a game state there. And so what this is going to do is this is actually going to be what our game state, this is going to be our state that we are running. And what we're going to be able to do is we're going to be able to do a few different things. So first off, we want to come over here, and we're going to want to have a void set state method. What this is going to do is this is going to allow us, and you're going to see in a second, I need to double check one thing. Check one thing. Is that actually a thing in C++? I know it is in other languages. I actually have not looked into this, and I apologize to this. Okay. This might actually work. So we're going to see if this works. I think that this will be very useful if it does. So what we will do is we will have that. Then we're also going to have a template here, which will take in a class T. And this class T is going to be able to create a game state, create class, that, oops, there we go, and return new T. And basically what that is going to let us do is that is going to let us create the class by passing in the class type as the type for it. It's a pretty straightforward method. There shouldn't be any huge issues with that except for the function set state not found. Oh yeah, okay, that makes sense. Okay, so there is that. Coming further down, we want to create this method now. And this is actually going to be, so here's what we are going to do. This is going to be real cool. So what we're going to do is we're going to have our template class T here. And then set state. So there's that, and then we're going to come down here. We're going to have void application set state So there's that. We're going to put that there. So there's that. Now, this is where it's going to get pretty cool. So what we're going to do is we're going to first check if this state, let me go back to the chat, make sure I don't miss any of you guys. So if this state does not equal null pointer, then this state destroy. And that's going to make sure our state is destroyed. Then we're going to come over here, we're going to do this state is equal to new t. Then we're going to do this state init, and we're all set. So what this is going to do, and it's a pretty cool little thing here. So really our state is going to update based on, it doesn't actually need to be, well, let's go ahead and we'll show how this works first before we do anything else. So what we're going to do is we're going to create a new item, and this time we actually are going to use the class wizard because of the fact that this is going to be an actual class. So the class name we're going to add is going to be test state. The base class is going to be game state, and it's going to be public, and we're going to do finish. And there's that. We're going to say virtual functions methods. Okay, that should be good. Let's go ahead and we'll do that. There's that. Oops, it did not work the way I wanted. Okay, that did not work the way I wanted. So let's go ahead and we will delete these two real quick. Delete. Now we are going to try that again. Class wizard. There we go. Test state, add class, test state, base class is game state. I guess that is not going to work the way I want it. Oh well, okay, so we're just going to have to implement these ourselves. So we have our test states here, we have our constructor and our destructor. And what we need now is we need several things. We need a bool init, bool update, and bool destroy. And then we're going to come over here and we're going to implement each one of these. So I'm then going to reorganize this a little bit more. And then we're going to take this, bool, init, bool update, bool destroy. And there is that. And these will return true to each one. Nope. And there's that. There's that compiling. And now what we're going to do is we're going to take over in our update method. We're going to take these two and we're actually going to put them into our test state. So our test state, upon initialization, will set the clear color to red, and then it will set up that buffer there. The other thing we want to do is we want to take our Windows and our GLGL stuff, and we're actually going to put that over in game state since that's the only place it's really going to be used. Did that not copy? Oops. And now that is all set up. The final thing that we are going to want to do is in our window.c++, we actually, or sorry, application.c++, we want to make sure that our game state is updated each time. So we're going to do that, state update. And we're going to then set active is equal to that. And then we're going to say if this, do if that, actually that's not going to work the way I wanted it to. So we're saying that, and if this active that. And really, that's actually not going to be the best way to do that. Really what we actually want to do, because there are going to be times where we want to have this go on and not necessarily render the window. So this is actually going to this is going to identify whether we want the window to update, but if you want it to stop, then you're going to want to use the application.stop. So there's that. We're going to run that real quick. I'm going to show you what that does, which is actually nothing as of right now, and the fact that it's going to do that. So we actually want to do one more thing which I forgot about. We want to make sure that it's not a null pointer. And application. Should be okay. There we go. So now that's set up to be null, so nothing happens. Now what we're going to want to do is, over in our main, we're going to set up in the initial state application instance set state. And we then want to add in here test state. Include test state. So there's that, except for the fact that it is planing to state, set state. That should have worked. I'm going to call it resolved externals. What is going on here? Sorry guys, I messed this up because I have not rehearsed this enough. Resolved external symbol, da da da. Maybe that isn't going to work the way I wanted it to. Set state, class test state, void, set state, reference in SDL main. Weird. That should have worked. There we go. That'll work for now. So there's our window running as expected. The reason for this, long story short, the class hasn't been set up properly yet, and so it's causing issues with that. Really, another way you could do this is you come over here and maybe do it that way. I'm not going to really worry about it. Well, I guess we can do it there. See if that works. Yeah. That, and then if we run that, that'll set up our initial state. Now the really cool thing about this, and we can go ahead and we can do class wizard, and when we will do add class, test state 2, base class, game state. Okay, so that gives us our other two test states, and what we're going to do now is we're going to take these, these into here, and then we're going to go to our test state C++ file, and we're going to take these we're going to copy them over, except this time it's going to be blue instead of red. So we're going to change this. First off, we're going to change these to test state 2, change that to 0, RGB, so there's that. And now what we can do is we can actually come over here. So you'll remember that we have, if we come over to our application, right now our update is set to happen here. What we actually want to do is we want to update this. And we're going to want to instead change this up. Because again, I don't particularly like this. I apologize, I have not really rehearsed this beforehand. This is all me going at this live. And so it's a little bit more disorganized as a result. We're going to take this. Sean got swag. Yes, we are going to be using OpenGL. That was one of the questions. Right now, we are currently going through game state management. So that is going to be happening. It's just, I'm also focusing on making sure that we can have a good state to run the game in. So in this case, if we have our key down stuff, we want to then pass in the event key symbols. I'm going to do this kind of lazily. This is not per se the best way to handle this, but it will do in this case. So what we're going to do is anytime there's a key down, we're going to just detect it. So there is that. And now our update method over here in game state is going to need to reflect this. So we're also going to need to include SDL2 / SDL. And in this case, it is of type. If we go here, we can actually hover over and see what the type is. It lets me, otherwise we can just do that, see that it's key code, and then we will come here and do key down. And this is actually not going to be the best way to handle that either, because that's only going to update weird. So we're going to go back to this. And we're going to get the keyboard a little bit of a wonky way. So right here, what we're going to do this SDL keyboard event is key. Oh, what is it? SDL get key state. There we go. Key 8 state is equal to SDL get keyboard state. Get all the keys. If state SDLs, we will do SDL scan code right. And for now, we're just going to do std cout key down. And we will want to come over here to our game state and include stream. Make sure that this works real quick. You can see right there that it's printing out when we press that. So now what we're going to do is, rather than doing that, we are instead now going to do application. We need to include that as a result. So I'm going to include application. Okay, and we're going to do application instance set state. And in this case, we're going to do test state 2. Which means we will need to come up here and do get that. Hopefully this will work as expected. includes game state includes that application, includes game state, that's all got pragma once though, so that should all be fine. What's going on here? What is going on here? Syntax. Error, missing, colon before star. Why is that complaining about that? Let's do this. Okay, there's that. However, that is still complaining. What is going on? Probably because of how we're passing that in. Okay, I guess we won't be using Singleton pattern then, just because this is not going to work the way I had hoped. So we're going to restructure some stuff real quick. I apologize for all of my silliness here with this. So there's that. Come here. Game state. H. Private variable app there. And this is going to get a little tricky real quick. So what we're going to be doing is we're going to be using dependency injection just to keep everything a little bit simpler. And so we're not dealing with a whole bunch of headache later on. So we're going to go ahead and do all of that. Now we need to go to our main class. And we now need to create application. App is equal to new application. App. Set state to Now we need to go over here and we need to make our application methods here public. So there's that. So this will let us create our applications there. I'll app.run and then that will be destroyed at the end there. So there is that. There's that. Okay. Syntax identifier application. And then what we're going to do is we are going to have our game state be in there. Find that here. Delete this. Delete. And then we need to fix our game state headers in various places. Remove those, and I will explain the rest of this very, very soon here. And there's that, game state. That needs to be passed into there. Class game state. And this is usually where things get a little tricky. And see, the issue is that this is expecting a definition for the class game state before it's actually created. And so this is where I should have planned this out a little bit better. I apologize for that. Let's go ahead for now. We're going to get rid of that. This here, make sure everything else is working before we fiddle with that. So we need to put that there. There's that. Test state 2 includes application.h. That should include Windows. That, and then we're going to need this to include that there. And now I'm going to delay that real quick because we're going to need some other stuff. SDL main. Interesting. Why is that not working? Unresolved external symbol class. I'm surprised that's not working still. Well, that means that was all for naught. We will keep doing this for now. We need to figure this out. So this is in our main method here. It's actually having issues at this line. This is the precise line it's having issues with. Let me see. It might be because of how we are doing this here. Let us come over to this and set that up here. I didn't think would work. So I really don't want to have resolved. What if we take this? Might have to do something wonky like this. Really hope not. And it didn't work. surprised this is not working as expected. Oh man, this is a tough one to do. Definition of the member function for the template. Weird. That's what we just did, but that did not seem to work. Template, class T. Yeah, that should be working. It's not. Templates can only be created when the template parameters are known, so they can't be compiled in advance. I'm guessing then that this is not going to work the way I wanted, so we are going to have to do some massive weirdness with this. Which I don't particularly like. But we don't have much of a choice. So, state. Okay, equals new is equal to state. So there's that, and then what we are going to do that, and then we're going to have a template class T state, and this is then going to take in our application state to new T. Over here. That should hopefully fix that. And now if we go there, that all fixes it. I'm not sure why Visual Studio is not letting that work. I think it's something to do with that. I will look more into that and we will maybe fix that next time. But basically, you cannot put this virtual method into here apparently, into the header file due to the way that C++ handles templates. Basically, they are compiled. They are not pre-compiled, and so that causes some weirdness apparently. We will resolve that next time because this is starting to run a little bit longer than I had hoped. Now I want to come over to our next state here, and I want our test state to hold an instance of app. And really, all of our states should have an instance to the app. So what we're going to want to do is we're going to want to come over here to application, game state, and we're going to want to have a private section. And this should have application app. Hopefully that will not yell at me, or it will. That's going to yell at me. So okay, so in order to fix this, we need to basically have those tie in together, which is going to be a bit tricky. The only way I'm thinking maybe we could do this, maybe we can do a class within a class, but that's very ugly. I really don't like that. So the final way that we could do this is we could have our application actually go through and handle all of this. Basically, our main state would be the application class in and of itself, which the more I look at this, the more I'm seeing that might be the best option for everything. So what we are going to do is we are going to, well, I don't like that though, because then we're going to need a global variable, and I consider those much, much worse in this case to have. So we need to basically have the game state contain a section of the application, and so game state, we need to be able to set the next state. So really the only way that we are going to be able to do this is having each state self-define that. Unless we do game state virtual base. So we have that, which would have kind of a base way to handle this. Real weird. So basically that handles all of our methods. And then game state class, game state public, game state base, which will have a private section with application, app, public, game state, application, app, there's that weirdness, and now we need to have our constructors reflect this. So we have application app, and then we come to test state 2. Test state 2 is the same way. We have that. Okay, so there's that. We have this. We have our set state, which takes in this app. Which application, game state, application, that should be protected so that our subclasses can see it. Test state, no default constructor available. And then that needs to pass in the app there. And then set state, no appropriate. That needs to be state base, which will not work. Well, maybe that will. Yeah, there we go. Woohoo for all of our inheritance and polymorphism. So now we can go ahead and we can set this up. I will explain all of this in just a moment here. To that, we'll set that to test state 1. So now if we push, oops, I need to do one more thing. Change that to left. So now if we push our right keyboard key, we will get to test state 2. If we push the left keyboard on test state 2, we get to test state 1. So now we can switch back and forth, and this is not using our previous way of Singleton structure. So now we're going to be using dependency injection just to make our lives less chaotic. So to explain what's going on, we create our application app right here. We set the state to it, which is going to be starting out with a test state, and we're passing in the app so that it knows what app is setting the state for. And then we say, while we're running that app, we're going to keep going. Now, if we go into our application, there's a couple things in here. This might seem a little overkill, but it will make sense shortly. Basically, we have our exception, which we've been doing before. We have our game state base, which is just kind of our base game state. It only has like an initialize, an update, and a destroy method. Which then in our application we actually set the state to that game state base. Now once we've set that, basically the set state, all that's going to do, if we come over here and we look at that, is it takes in a pointer to a state. We have that state here, and basically that is going to check that the previous state is not null, and if it is not null, then we destroy it. That cleans up all of our stuff. That's where our destructors, that's basically where everything that gets cleaned up goes. Then here we have our state is equal to the new state that we're going to, and then we have to initialize that now that the previous state has been cleared up. And the way that we actually call this, we could call it here. However, the better way that we end up calling this is we actually come down here and we have our state here, which this class basically takes a template, and the way that a template is specified is you have these little less than greater than symbols with whatever state is in there. And so what this allows us to do is we just need to pass in the application. We don't have to create a new instance in there. It's a little bit of a trivial thing, really. We don't technically need this. We could just call it from here. I'm just kind of doing that because and this will basically let us set the state, and then once we've set the state, it will create a new instance of it, passing in the app as the input parameter for this game state here. This game state then will take in our, and actually what we can do is we can do this two ways. We have that, and we can have one that does not pass in the app, which will be useful for any of the ones where it does not do that. And actually, I don't think this is going to work the way I want it, so we're not going to worry about that. Anyways, and so this will then create a new instance of whatever state we pass in. We can go ahead and we can actually rename this state class, and that'll create our new state class, passing in the app, and then it will have the app set that state. And so in our test state, for example, when we press the right keyboard key, we utilize that to set it to test state 2 and pass in that app. And in test state 2, we do the same thing, but for the original test state. So what this means now is all of our focus can be put in to these methods here, which basically what these are is we have our constructor, our destructor, and then we also have our initialize function, which is where we actually initialize all of our code. We have our update method, which is what updates each and every time, and then we have our destroy method, which is where we will clean up everything after. And so right now all we're doing is we're setting the clear color to blue here and red in test state 1. We clear the buffer through each frame, and then we check the keyboard key and then set the state accordingly. If we're on test state 1, we press right and it goes to the second test state. If we push left, it'll go to the first test state again. So that's really all I'm going to go over for this time. Again, next time, I apologize for all of this. We started out with Singleton. We switched over to We then switched over to dependency injection, so that's going to be a little bit more proper and a little bit easier to manage. And the purpose of these videos is not really to go through and make the world's best video games, to make something simple, straightforward, and kind of just showing the process, some of the errors you can come across and how to fix them and things of that nature. Part of this is I need to rehearse these better, and I apologize. Between all the snow this week and everything else, it's been a little tough, but the big goal is we're not trying to create the world's best game. We're not trying to create some revolutionary game engine. We're just trying to make a cool game that is fun to play and such, and that will let us go through and learn how to do like a small independent developed game. That's really it for this video. Next week we'll be going over, starting with our OpenGL stuff, we'll be going over some of the math behind it and stuff as well, but we're basically just going to focus on getting a quick little thing rendered, and then we're going to grow everything from there now that we have our game states set up. And so this is kind of the format we're going to be using. We'll initialize everything in here, we'll then update it here, and then we'll destroy everything here, and that'll be the way that that works. So, thank you guys for tuning in. I apologize for all the delays. The links right here will be in the description of the video below. Yeah, so thank you guys for tuning in. Hope you guys enjoyed this. Apologies for the delays. Apologies for the misinformation. You know, I've done OpenGL before. I have not done it with SDL, so this is kind of my first big project with all of this. So I'm kind of learning some stuff as well. I'm also trying to really make use of C++11 features and trying to use a much more object-oriented approach rather than a very methods-based one. So this is kind of why this is slowly taking some time, is just structuring it so that the game is easy to manage, easy to go from state to state, but also making sure that it is not using bad things like global variables, which are generally just a mess to use and have around. So thank you guys for tuning in. I hope you guys are finding these videos useful. I hope that they're not too disorganized for people. Thanks for tuning in. Next week we'll be starting on actually 3D rendering something. So see you guys next weekend.